packet pushers.
Welcome to the IPv6 Buzz, where we dare to dive into the 128-bit address space wormhole. I'm Ed Horley.
And I'm Scott Hoag. On the show, we discuss all things IPv6, strategy, design, deployment, and operations.
And I'm Tom Coffeen. We've spent 20 plus years working with the IPv6 protocol. We run a consulting firm where we get IPv6 working for our customers.
And we're here to share some lessons learned and how to avoid common mistakes. We're glad you joined us today. We're back for another IPv6 Basics. This time we're going to be covering router advertisements, which is part of the neighbor discovery protocol. So let's jump in. Let's just start from the beginning, I guess, about router advertisements. I guess the obvious is that router advertisements use ICMP version 6, but we can cover that in a little bit more detail throughout the show. Where do we want to start? How a host actually bootstraps itself and gets on the network? Does that make the most sense?
Yeah, I mean, an IPv6 node, just like an IPv4 node, could have a statically configured settings for its address and its default gateway and things like that. It's the same for v4 and v6. They could have addresses set, and then there would not be a need for any kind of bootstrapping. It's hard-coded into the node configuration, but nodes can boot up and need to bootstrap themselves and figure out where they are, how they connect, and they need some guidance from the router to tell them where they're at and how they go about obtaining their address.
Right. And the first thing they do is they have to basically create a link local address, right? That's the first thing that all these devices are going to do. And we've talked in previous shows about what that looks like.
Yeah.
So I don't think we have to cover that in any detail. But once you've got a link local address, you have the capability to participate on the wire and send something out and say like, hey, I'd like to get some information to be able to configure something, right, in terms of participating on the network if you don't have something manually set up already.
Yeah, and I think it's important to point out operationally the model is different than what we're used to with v4, where you get an address via DHCP. You're not really relying on the router. I mean, there might be a relay command in the router to get the request to the DHCP server, but there's additional configuration on the router that's required for auto addressing in IPv6, whether that's DHCPv6 or Slack. And that's where the router advertisement comes in. So if you're just thinking about it from a v4 perspective, it's definitely a shift in how you're configuring everything.
Yeah. In IPv6, I always say, you need an address to get an address. And you start with this link local address, this FE80 address, which only has link local significance, but it's the first address that your node starts with to start to talk to other nodes locally. And one of the nodes the host needs to talk to is the router or any router on the network. It needs to say, hey, I'm here. Now what do I do?
How does the node figure out how to do that? What's the thing that it does process-wise? I'm a host of a device that comes up on the network. I need to do something when I first come on after I've configured my link local address. We either are going to ask for something or maybe we hear something on the wire, right? One or the other. Probably more likely that we're going to ask for something because the intervals probably aren't all that frequent that a router is going to send the information on the wire. Otherwise, we create a mess, right? In terms of sending information out too quickly. But we're probably going to do a router solicitation. That's the standard set for what hosts are going to do, right? Is they're going to solicit for that router information. They're going to ask a well-known address, hey, what are all the routers that are on the network? Can I find out some information, please? And so you're going to do that router solicitation, which is an ICMP version 6 type 133. And send that off on the wire. And that's to a very specific address, right? That we're going to send that to. And that's going to be a multicast address. So all the routers on that given layer 2 segment, right, are going to listen to that on that well-known multicast address. Routers are the FFO2::2, right? That's the all routers on the network. So that's where you're going to send the router solicitation. You're going to, I guess, hoot and holler at the routers on the network and ask for information. The regular thing that you yell on the wire, can you just send that over to me so I can figure out what I need to do for myself, right?
Yeah, all the routers on the segment are tuned in and listening for any packets sent to that LAN-based multicast for any node that might be, hey, I'm here, and so the routers are tuned in to that, listening for router solicitations. And when they hear a router solicitation, they respond to tell that host where they're at and what's up.
Yeah. And then besides the solicitation, as the show title is for router advertisements, routers advertise periodically, basically to keep everyone sort of updated. So they send a router advertisement out, and that's a different type. It's an ICMP version 6 type 134 that goes out on a regular interval, something you can adjust, but it's set at a regular interval for the routers to sort of talk on the wire and say like, hey, everyone, we're still all on this prefix. right? And this is the prefix that we want to use. And we're all still doing DHCPv6, or no, we suddenly added Slack, right? So those are the sorts of things that might change periodically, from a router advertisement basis. Although I have a feeling if you're making those changes on your router, it's going to send a router advertisement immediately the moment you change those, but not necessarily at the interval time. But that being said, that's sort of the function of the purpose of a router advertisement going out on regular intervals, sort of reassuring you're on the right network with the right config.
How frequent are the router advertisements? I know there are probably different defaults for different systems.
Typically, like a Cisco router, the default is every 200 seconds, which is eons in network time. That's a long time, but these are the updates that are sent just to keep every node updated. But as soon as you go into the router and make a change to its settings on that particular interface that are related to the router advertisement, it immediately sends a new one.
Right.
Like immediately, as soon as you put in a command to change, let's say, the interval or any of its settings, boom, it sends a new one right away.
Yeah, it updates immediately.
And then if you make another adjustment, boom, it sends out another one. So it's adjustable on the router's interface as well. Different vendors may have different settings. If you're in an environment that's quite volatile, maybe you want to send them more frequently, like in AWS. They're sent by the synthetic router on the subnet every 10 seconds. I've seen some CPE devices at people's homes, like on a Comcast CPE device, 4 to 5 seconds, pretty fast.
Yeah.
But if you were on an IoT network and you wanted to conserve battery life of constrained devices, you could send them once a day, maybe.
Yeah, you could send it whatever interval the manufactured device for the router supports, right? From a config basis, you could set super long ones if that was something that you really felt like was important to do. I don't know if that's typical, but I think most folks probably don't change their RA advertisement settings. Probably just a guess.
Yeah.
But I would say that they probably just leave with whatever the default is of the manufacturer.
Which in most environments is fine.
Yeah.
Perfectly acceptable. Yeah.
And even if the periodic RAs are set to 200 seconds, if a node joins in the midst of that 200-second interval, that node will send a router solicitation, which will immediately trigger a new router advertisement. So a node doesn't have to wait 200 seconds for the next one. As soon as a new node joins, there'll be an RS, and that'll trigger an RA. And then the routers will go back to their normal periodic rate.
And I think what's important about that is that the return traffic that's coming from the router, because it knows the destination, it doesn't have to send that out as a all nodes FF02::1 response, right? It can send it directly to the destination.
It'll unicast it, right?
It'll unicast it as opposed to necessarily on the wire, right? So
yeah, and that's something that might be done in a wireless LAN,
right,
to preserve, multicast, replication, or in an IoT network where you don't want to tell all the nodes about something they already know and conserve battery life.
right. You don't want to wake them if they're on a sleep interval. Yeah. So it's a good point to sort of understand. And the source and destination portion plays a role in sort of the efficiencies that you get at scale for IPv6, because this also allows for a tremendous number of devices to be able to provision and not have the problem of like race conditions with like too many devices asking for addresses at the same moment, things of that nature, right?
Mhm.
So depending on whether you're using DHCPv6 or Slack. Cool. So we know that router advertisements are sent out as a response to router solicitations if those come in, but router advertisements are also sent out periodically. So we've got that in the bag. We understand how that's sort of working. I guess we never really talked about what the true function of the router advertisement is, which is basically to provide the key sets of, are you self-provisioning an address? Are you using DHCPv6 and maybe some other optional information that's provided in the advertisement itself, depending on which mode you're using. So I guess we could jump in and cover what sort of information is contained in the RA itself, right?
Yeah, the RA can have a whole ton of different types of options in it for different types of information that it needs to communicate to the node. And these can be customized for any particular network. So if you had a router in your data center, you might have certain settings and share certain information with servers. If it's a router on an end user access network, it would have a different configuration and it would have a different set of options. And you would configure these on the router with commands, or in a synthetic router or a router advertisement daemon. You could customize these options. So not all of your networks have to have the same set of information. You might have one router advertisement in an IoT network that's much different than maybe an end user network or a guest wireless LAN.
Right. And that makes sense. So that gives us the flexibility to be able to provision addresses in a way that, the network function sort of defines. It makes the most sense for it operationally.
And just to point out again that these are usually siloed functions where it's like, okay, there's network operations peanut butter that gets in your client management chocolate, where, like normally you're not maybe used to having to configure things on the router interface to get clients up and working properly.
Yeah.
And so there has to be some shared responsibility, and sometimes that can create some confusion, some operational challenges, related to who's responsible for what and making sure those configuration changes are in effect. And
yeah, because on V4 networks, the only thing the router administrator has to set is the IP helper, the DHCP relay.
Yeah, and then hope that whoever sets up the pool sets everything up correctly, including the default gateway for the router.
That's right.
Yeah, exactly.
I think the decision was operationally to move a little bit more of that control back over to the network side with IPv6. So there's definitely some shared responsibility still, but I think the realization that the router itself is the default gateway, sort of by definition, by the way that the router advertisements are defined, it's declaring itself the default gateway. Although you can obviously have more than one, and that's probably for another show, but we can at least acknowledge that the router advertisement should be coming from your default gateway router that exists on any given network segment. So I guess there are a couple flag settings that sort of indicate some information in router advertisements, and then there are a couple sort of optional prefix option bits that get set. And I'm just like everyone else, I'm horrible, and I say, A, M, and O flags, even though I think A technically is an option bit along with the L bit. This is getting into the weeds for everyone, but
it is and it isn't, because when you go to actually configure these options in the router, the way that the parser structures the choices is based on like exactly what you just described. You have flags that are set, the M and the O flag that are set at the ICMPv6 packet level, just within the main packet itself. But then you have the options that include the prefix information option and also the autonomous flag that actually indicates to the host to use that prefix information to build an address.
right.
And so the way those are all sort of structured and break out from each other can be a little confusing on the the command interface when you're like trying to figure out what you're trying to activate and where it sort of sits in the overall command structure. Because in the case of iOS, they've sort of modeled it after exactly what we just described, with everything sort of broken out in that way. And so it's a little bit like having to hunt down the option that, just context sensitive help can be your friend here. It helps to know the terminology so you know what you're looking for and you can get the right configuration set pretty easily.
The M and the O flag, basically that stateful DHCPv6 option, which is really saying like, hey, I want you to get an address from the DHCPv6 server, right? And then the O flag, which is really originally was part of the stateless DHCPv6, right? For getting all your other information from, your DHCPv6 server, right? It might be DNS information, or it might be TFTP server information, or NTP, or things of that nature, that wouldn't be originally provisioned in the RA at all, but you needed to have some way to get that information off the network. And so you sort of had these combinations. I think today the interpretation is like, if the M flag, you don't necessarily need to have the O flag enabled, because you're going to be going to the DHCPv6 server and it's probably going to provide you all the information you need anyway. So the O flag is sort of redundant at that point. We used to make the recommendation, just set the M and the O flag together.
Is that still our recommendation?
I don't know. I think it's just leave it the M flag. I think it's just the M flag.
I think the M flag overrides the O flag.
Okay.
And the O flag was legacy, because back in 2006, we had nodes that didn't support DHCPv6. And so the only way to communicate that other information to them was through this O flag setting. Now, almost all modern host OSs support DHCPv6, and the M flag being set to 1 and the A flag, the auto configuration flag, being turned off tells the host that it should do DHCPv6, although the M flag overrides the A flag. So if the M flag is set to 1, that will force DHCPv6 and override any A flag setting.
That was for older clients though, because it used to be back in the day, like Windows, like 2008 R2 and like Windows Vista. I think like they didn't send out a DHCP client request unless they saw an M flag.
Linux will wait for the M flag to be seen before it sends out a DHCP solicit, where Windows will send out a DHCP solicit even if it doesn't hear the M flag set to 1.
That's right. Yeah.
So there's some nuanced things about like some behaviors you'll get on client machines based off of what your router advertisement settings actually are.
Yeah.
So I think that's important for folks to know. I guess we should finish off and talk about what the A bit is actually all about. because it's probably the next most important. We usually talk about M, O, and A commonly on the show. And
Mhm.
the A bit is really all about saying like, hey, you should just, if it's enabled, you should be self-provisioning yourself an address, right? In terms of the prefix that you're seeing that's being advertised from the router, go ahead and build yourself an address automatically. And all the ways that we've talked about in past shows around, UI64 or privacy or temporary, all the different ways to sort of build an address, do all the things right with that prefix and go ahead and do it. And there's no restriction on how many prefixes necessarily you can advertise within the router advertisement. I guess there's probably some practical limitations for each one of the manufacturers in terms of how many they will support, but if you wanted to, nothing that would say you couldn't advertise multiple prefixes at the same time on the same interface, right?
Yeah, you totally can. You can configure 2 prefixes.
Yeah.
And there will be 2 option number 3 prefix information options carried
Right.
in that one router advertisement. So yes, I've done that before.
Good for renumbering, right?
Yeah. Your node will have 2 addresses. And then the question is, well, which address is it going to use and which one is going to be bound to the default route?
Right.
Your mileage may vary.
That's right. Did they share lifetime values though? That's the thing. Can they be set separately?
Yeah, 2 complete 3 PIOs will be in the RA. It's like it has 2 PIOs in the one RA.
Yeah, so it's just to make life that much more interesting for everyone, and you can have that. And there's another bit, the L bit, that's basically a way to indicate whether that particular prefix is actually on link or not, right? Whether that host can actually use neighbor discovery to find other resources, right?
Oh, let me just finish one thought here. Tom, you were asking why you would want to do 2 PIOs. One PIO would be for your global address. One PIO would be for your ULA address.
Oh, yeah. Interesting. I could see that configuration for those that are brave enough to dare deploying ULA on their networks.
To ruin their live and future network ULA.
I always credit Scott for coining this one of coming up with like the Christmas tree RA, which is like setting all of them, turn all the bits on. You have all the lights flashing.
I guess I coined that term, but it was Comcast who really set the bar really high by turning on everything on their residential CPE devices.
They want to make sure that you understand that you need all your addresses configured
Set
through
all
us.
the flags, set all the things.
All your flags belong to us.
Yes. I love it.
Yeah, so I guess we could dig in a little bit more into the options that exist for the prefix. So we talked about the A and the L really quickly. I'm not going to spend too much time on the L because that's sort of down in the weeds and not necessary. But I think there are other interesting option settings that exist for the prefix information that we would provide. So for a given prefix that we would advertise on a network, a /64, just to be clear, it's always going to be a /64. That's part of at least the auto provisioning portion. If you've got the 8-bit set, it needs to be a 64.
Not a /65?
No,
No,
not a
no.
65,
do
not a
it.
99, 96, not a 120.
You'll make us cry.
Not a 112/112.
Don't make the IPv6 Bud podcast host cry.
Okay, we'll stick to /64 then.
Yeah, so there's a couple different options that exist in there. We talked about the prefix portion, which is option 3, right? Defines the prefix, and the host provisioning, which is that L flag portion. I guess there's also some options around, I guess, DNS server information and DNS suffix information. I guess those would be the next, at least in my short list, probably the next obvious ones that I would probably want to set because I want to make use of our DNSS. We've talked about it in previous shows, but that's sort of being able to provide DNS server information and DNS suffix information in the router advertisement so that the host is able to get the most important information it needs, which is it can provision itself an address. It knows where its default gateway is because the router advertisement is coming from that. And then it's got a DNS server, right, to be able to go do an actual query to be able to find other things on the network. Those are the 3 critical.
Yeah, and that's kind of what obsoleted stateless DHCPv6, right?
Yes.
You no longer had to, have this sort of bifurcated operational model where you have, okay, I'm going to get my prefix and build my GUA from a prefix from the router advertisement, but hey, now I still have to rely on a DHCPv6 advertisement to learn what the DNS server is. With our DNSS, you can just, it's one-stop shopping and get all from your router advertisement.
Yeah. So I think those are probably the 2 next important ones. And the suffix list is obviously important from the aspect of saying like, hey, this server information, this is the network you're on. This is the DNS namespace you're on. These are the ones you should be looking up where and how. And the DNS server information, we can have multiple, right? So we can provide a sorted list of DNS name servers that you're supposed to be utilizing via that. I don't know. What other options do you think are super critical that folks should probably know about?
Yeah, almost every RA has an option 1, which is the link local address for the router.
Oh, yeah,
Inside the RA, the router says, hey, here's my link local address, my MAC address,
right.
because you're going to need to know this anyway. And it just saves another neighbor solicitation and another neighbor advertise. So that's one that's always in there because the router's like, hey, you're going to need this to be able to send me an Ethernet frame.
And once again, an operational departure from DHCPv4 where, hey, we want the gateway address, you're going to get it from the DHCP packet. So here we're getting it from the router advertisement, and you can't neglect it. Probably the main reason, if you want your traffic leaving the local link, then you need to have that next hop of the link local address of the router that's provided in the router advertisement.
And then option number 5 in the router advertisement is the MTU, the IPv6 interface MTU.
Right.
Most of the time, this might be 1,500 bytes on an end user access network, but in a data center, you could set this to 9,000 bytes, for jumbo frames.
And what's the smallest MTU?
1280 bytes.
1280, yeah.
For IPv6. Also, your V6 MTU doesn't have to be the same as your V4 MTU. It's really protocol specific.
Yeah, that's a weird one, right? In terms of that could throw things off and you could have things diverge.
You should have them be the same. Like, it's too complicated already. Have the same MTU, but it gives you the option to do that. And it's more difficult to do that in IPv4, where you'd have to set it on the host and set it on the network equipment. You'd have to go server by server and make sure in a data center you're using jumbo frames. But then here, with a router advertisement, you communicate that to the nodes with one RA packet.
Yeah, and they can choose to send something smaller on their own if they have a smaller MTU. But the reality is that you're basically advertising what this routed interface will support from an MTU basis. All right, what else is super important? What other ones do we think option-wise are going to make an impact for folks to pay attention to?
There's a lot of other esoteric ones, and there's more being added every day.
Right.
We're coming up with new ideas for IPv6, even though IPv6 is pretty widely deployed on the internet, it's continuing to evolve as a protocol as we gain more operational experience with it, and new ideas and creative approaches are adding additional options to the RA.
Yeah, I think the interesting one that we've talked about recently is in terms of being able to support transition technologies around IPv6 mostly. The last show that was just on is option 38, which is the Pref64, having the capability to provide what that NAT64 prefix is actually supposed to be, right? That's pretty important for those that are making use of transition technologies. You want to be able to know how that information gets out. That's exactly how it's being provisioned on the network. So if you have a device that recognizes that option, and that's a client side thing, obviously the router needs to support it too. But if you can put that option 38 in there, then you can specify what that Pref64 prefix actually is. So I think that one's pretty important for folks that are working through transition technologies, which are pretty much going to be everyone. There's going to be a bit of that in there. What else do we feel like is important to cover?
Yeah, that's most of the common RA options.
Yeah, I guess the router advertisements we didn't cover sort of at the top of, but if the router is just sending out a generic router advertisement, it's going to send it to everyone, right? Sort of across the board. And so it's just going to make use of that multicast address for the all nodes multicast address, right? That FFO2::1. So it's basically, it's going to look like a broadcast effectively.
Yeah, it's the closest thing IPv6 has to a broadcast.
You're going to see that router advertisement hit that FFO2::1. And that's probably why you're not seeing it as often, just to avoid that potential issue of like interrupting everyone in order to send that payload out. So it's sort of restricting about who you want to be able to send to that FFO2::1 on a regular interval. I guess we should make note that part of the router advertisement process would make use of your solicited node multicast address, and we've covered that in other shows, and we'll probably, dive in that a little bit deeper at some point, but just realize that, that is an important aspect of router advertisements and, neighbor advertisements and neighbor solicitation and router advertisements, router solicitation, right? That's all baked in and part of it, but we won't necessarily dive into it here. In this part here, it doesn't necessarily make sense to cover it in detail. I guess I'll ask you both, are there use cases where we don't need router advertisements and router solicitations? Is there a use case where you might not want to have those two things happen?
I guess anywhere where you might have static configured nodes, then they don't need the router advertisement.
Right, because they have all that information. So maybe if you're doing automation, I would think maybe in a data center where maybe you don't want someone to plug a device in or have a virtual machine come up and just have it self-discover router advertisement, DHCP itself address, or do a automatic address of any type. You would just not have any router advertisements that are happening on that particular network segment. You're never going to reply back. a host can ask all at once with router solicitations, but no one's actually going to reply.
That's right.
So they're screaming into the void.
Yeah, or a cloud environment.
Oh, yeah, good point.
In those cases, when a node is statically configured, it won't send an RS.
Right.
And even if it's statically configured and it hears a router advertisement, it will ignore that because it's been static. Different operating systems behave slightly differently here when they're statically configured. Some will have it be static and not hear the router advertisement. Some may still hear the router advertisement.
Some of them with the A flag, they will provision themselves some temporary addresses in addition.
Yeah, they'll have their static address and a temporary.
Yeah.
You're like, what? What's going on here?
Should probably also mention the first hop security that can be turned on for router advertisement, the RA guard.
Yeah, sure. Yeah, okay. Since you brought it up.
Well, I mean, I know we do have first hop security in v4 land around things like DHCP snooping, which, the idea that you have certain ports that are configured for, having a router on the other side, and you shouldn't be seeing RAs showing up on ports that haven't been indicated that there's a router connected. So that basic security function that's in place, I guess, if we're just talking about getting all of this up and working, you might have that configured and not realize that it's, going on, and you could potentially misconfigure things, have the router plugged into the interface that has RA guard enabled or something. So just something to keep in mind.
Yeah, good point. Is there any other use cases where router advertisements, router solicitations might not work at all?
If you misconfigure them, I guess.
Yeah.
If you don't have a network that supports multicast, right, you're going to have issues.
Well, and then of course there's that impulse to shut ICMPv6 or just ICMP off, right? Okay, well, we're securing our network by disabling ICMP, and so we want to do the same thing in v6, and then all of a sudden, of course, you're breaking everything. You're breaking neighbor discovery, router advertisements, neighbor advertisement solicitation, etc.
Many commercial firewalls, even though you set an IPv6 address on the firewall, it won't send a router advertisement by default.
Right.
Even though it might be a default gateway for some hosts that are directly connected, you would have to go into its settings and enable router advertisements. But many firewalls turn off RAs by default.
Yeah, if you're relying on your firewall for your RAs, maybe you might want to rethink your overall configuration.
Or you have to go in and just set them manually.
Yeah.
All right. Well, I think we covered most of it. We'll link a bunch of show notes that give you more information to dig into around neighbor discovery itself, which router advertisements are part of neighbor discovery. And then also some links around all the ICMP message types and when you should or shouldn't be disabling stuff and having fun with first hop security, et cetera. So hopefully that'll be useful for you all. Thanks for joining us for this episode of IPv6 Buzz. If you've got feedback or a follow-up on this topic, send us a message at packetpushers.net/FU. We'd love to hear from you and continue the conversation.
Also, on packetpushers.net, you'll find a range of deep dive technical podcasts for IT pros, including heavy networking, heavy wireless, and day 2 cloud.
There's a whole lot more on the Packet Pushers site as well, such as tutorial videos and a networking job board to help you find or fill your next great role. So whether you're deep in your career or just starting up, Packet Pushers is the place to go to grow both your skills and your personal network.
So long and until next time, we'll see you on the IPv6 internet.